Hello everyone, welcome to my another video in Go. So in this video I will try to explain Go routines and Go channels. If you are not familiar with those things, they help us to write concurrent applications using Go. So I'm not going to explain what concurrency is because I assume that you already know what concurrency is. But it simply is being able to run things in concurrently. It doesn't mean it's gonna be run. They're gonna be run in parallel, but that means they're gonna be running concurrently. That means asynchronously or maybe in parallel. So when you normally write an application, you actually typically use a sequential programming style. That means let's go ahead and write something, and I'm just gonna write a simple sequential. Let's say series 1 and series 2. So as you see, it is just a sequential application. So if I run this application, what I'm gonna see very expected behavior, which is series 1 and then series 2, output it to the window. Of course, there are cases where you may want to wait. You don't want to wait, and some work to be done while you want to do other things. Let's assume that you have some CPU bound operation, or let's assume that you want to download a page, and then let's have a web page to your application and want to process the contents of it, but after you process the content, you also have some code that, let's say, get some data from database and stuff like that, and then all this data that it got from database, it kind of inject that data to the HTML source code that you download from a certain web page, and inject those variables or values to that HTML, and then let's assume that it just writes that to the console window. There are one thing that you can make in this simple scenario. As you see that you don't really have to wait actually for the web page to be downloaded, right? You can, while it's being downloaded, you can actually go ahead and grab the values that you need from database, and then you can say, hey, you can check if the web page is ready and download it, and then you can continue executing your injection logic. This is where the concurrency, one example where concurrency gives you a better speed and better performance, because you don't have to wait. Because sometimes, like, the I/O operations take time, and maybe the network is unstable and something happened and some whatever, or the web server of your of the target domain is slow. You simply increase the time of unresponsiveness of your application by waiting that web page downloaded. So that is in mind. We have this Go routines in Go programming language that simply gives us the ability to write concurrent applications. It's very simple. So imagine that between those two guys, I just had to download okay, so imagine that this amount of work here, which we wait 2 seconds, is that download operation. And imagine that this fmprintln is the database operation. So you simply had to wait this guy to finish before you can even process this third line here. Let's go ahead and try it very quickly. You see that we're waiting for it, and okay, now it's done, and then we can continue executing the third line. So if you don't like it, which I assume you don't, because you want to write a high performant application, so what you can do here is a very simple step. As you see that I have this Go function here, so that Go is the keyword that you use to make a function concurrent. So the second part of it is function, which is an Adams function here, within another function, and also I immediately execute it by appending these parentheses, open close parentheses here. That also gives me some closure here, which if you are somehow familiar with to JavaScript, you know what I'm talking about. I mean, in JavaScript we have exactly the same similar constructs, and then we use them a lot to kind of have a private block or private context, whatever. So this being said, now if I run this application, as you see that I just got series 2. That doesn't mean that the series 1 was not executed, because I don't know. What happened is very simple. Since the first go was, this portion was concurrent, we didn't wait until it is finished here, and then we just executed this line, and when there's nothing to execute after that, we simply quit. So what you can do, for instance, you can give some time this guy to execute. So let's say I'm just gonna 2 seconds. I don't know. I don't exactly know how much I should give, because it depends on your computer and your scheduling algorithm and stuff like that. So I'm just gonna go with 2 seconds, and that means, okay, I will execute this and wait so that this function can do something and at least hit this line so that it can write something to output window, and then it is done. But of course, it doesn't still give me. It doesn't still give me the. How can I say? It doesn't still work the way I want, because if this guy was like a long running process, it was possible that the 2 seconds will not be enough for this whole entire Go routine to finish, right? So let's go ahead and run this though, and you'll see that series 2, series 1. I'm still waiting a couple some time, and then it quits. So at this point, you realized that this is not a good idea. I mean, using timer like this, not a good idea to wait the Go main Go routine to finish other Go routines. So what is main Go routine, by the way? It is the first Go routine. When you run your Go application, a default Go routine automatically is created and executed, and that is the Go routine that runs your whole application. But you can of course create like more Go routines from that Go routine, main Go routine. So all this code, for instance, here, these are all executed by main Go routine. This is executed by main Go routine, but within this function, it's executed by another Go routine. So this whole line executed by main Go routine, but this guy over here is executed by another Go routine that we created by using the Go keyword here. So this is still a good idea here. At this point, and if you're coming from a different languages, you say, I wish there was something that kind of like a signal mechanism that tells from other Go routines that I am done, so that main Go routine can check it and say, okay, these are done, so I can continue finishing up. And in fact, we do have one thing, and that's called channel. So there are a couple different channels. Actually, there are 2 channels, and one is called unbuffered, and the other one is called buffered channel. In this example, we're going to use unbuffered channel. Buffered, as you see, like buffered channel means like something you can add to it continuously until a certain point, so that it does something. You know, we use buffers a lot in our computer lives, and in fact, like buffers. It's like loading a truck, right? And then when the truck is full, at that point you say, okay, I'm gonna drive this truck to whatever. I'm just gonna take this truck because it's full now. So the truck works like a buffer. You add to it until it is full, and then it's ready to go. So that's a buffer channel. But we just use gonna unbuffer channel. That means you can only add one thing. You can only sense one thing. By the way, when you work with channels, you will hear words like send and receive, not assign or read or write to read, whatever. It's because channels work differently. Channels are different construct than just simple variables. So let's go ahead and create our first channel and see how that works. I'm just gonna say done. In this example, done makes sense, and you use make function as if like you use where you use slices and maps, whatever. So you define your channel with this channel keyword, and then you said you define the underlying type. The underlying type is, in this case, is Boolean, because I want to say if it's done or not. So that's true or false. And of course you can say like int or whatever you like, but here it's just Boolean. And so what I'm gonna do here, it's very simple. So I'm just gonna I don't need this anymore because I don't care about the type. Oh, actually, I need that one. Sorry. What I'm gonna do here, I'm just gonna say okay. So that's how you send a value to a channel. Remember that channel uses different mechanisms and different underlying types. So you don't really assign a value, but you actually send a value to a channel, and channel uses the value and do whatever it needs to do. And then here, I don't need this timer anymore. So what I'm gonna do, done. So you see that it kind of looks weird. I understand that, but normally, like when you receive a value from a channel, that's how you do it. If you want to send a value to channel, let's put some space here and some spaces here too, so that it looks better. What is that? Oh yeah, result declared not used, but that doesn't matter. And then that's how you say I want to send this true to done channel, and it says I want to receive that value, whatever the value is in there, from this channel. But there are some important things to know about channels, and if you don't know these, channel doesn't make sense. And that is the way channel synchronizes Go routines, and that's really important about channels. One of the most important things actually about channels, they besides sending data from one Go routine to another, they also synchronize channels. So imagine this scenario. You have two cooks and one frying pan, and one cook, the first cook, puts something to the frying pan and cooks it, and then waits the other cook to take the content, the food, whatever, the meal from it, and then spice it. You see that while you see that the concurrency there. So while the first cook does something and then puts his stuff to the frying pan, the other cook can do other things. Perhaps like it's still working on the previous content that it got from the frying pan. And they don't have to wait each other. They only have to wait for each other when they're done. So let's say this first cook put things to the frying pan. Actually tries to put things to the frying pan, but it's still full. And it will wait until the other cook actually empty it. And so when it's emptied, and now the first cook can put his ingredient to it, and in the other frying, and then what I'm saying is that the first cook was blocked because of the fact that the frying pan was not ready. Why was not ready? Because it's still full. The other cook didn't empty it. So you see that the blocking mechanism, and the other cook, the second cook, it will be blocked if there's nothing in the frying pan. So he will just wait. But when he gets stuff from the frying pan, if it's not full, it just gets the stuff and start working on it. And at the same time, this two cook can work at the same time. And then they only get blocked when they need that the content of the frying. I mean, when they, based on the status or state of the frying pan, whether it's empty or not. Channels work in the exactly same way. What happens here is when the done is this is, by the way, unbuffered channel. When done is empty, then I can put value, I can send value to it, as in like you see in this Go routine. Let's execute this program. We don't need this. I'm simply, by saying that I'm saying I ignore the content, or I ignore the value that I got from this channel. All I want is the reason why I'm using this channel is for synchronization purposes, so that I can wait until this Go routine is complete. So let's say, we execute this program. Great, we have our channel now. We run this concurrent Go routine, and it just does its stuff. And while we're waiting for it, we also we printed out some data here. Great. And now we try to read this done. We try to receive value from this done channel, and we look at, hey, this is empty. I can't get stuff from it. At that point, the Go routine is blocked. The main Go routine is blocked and waits until something fills this done channel. And that is where our other Go routine takes into place. And it actually sends value to it. When it sends its value, this done, still waiting, and when it sees a value that added or sent to the done channel, it will just immediately read it out of it. Read that value out of the done channel, and then we'll continue. And that's how the synchronization happens. If you, for instance, so in an unbuffered channel, since it was blocked because the done was empty, same happens here too. If I try to send another value to our done channel like this, before anyone actually empties this guy done, then it will block me too. It will block this Go routine because done is not empty, so I cannot send anything to it until someone reads its value and empties it. And that's how the channels work. And at the second line here, we will be blocked, but here we wouldn't. So in fact, if we add some data to it here, whatever, we may still have some chance to run our extra code here until this is read and the program exits, like in this case. So if you understand this, you actually understand a very important aspect of Go routines and Go channels. So let's go ahead and run our application and see how that works. You see that we have series 2 and series 1, and while let's actually put some FMT here too. Series or done Go routine. Okay, some work happens there, here, and then imagine that it was the web page downloading, and then it's done and says done Go routine, and it sets our done here, and now we see some value sent to done channel, and then we read it, and then we continue. And since there's nothing after that, we exit. But I can do, of course, some println here and done the whole application, and then now I can run this. Okay, we wait for this guy, and then see done Go routine, and now we continue to the last line, and that is that. Imagine that this line was the injection of the values from database into whatever HTML came from whatever URL, and that's the thing. So we did it, and then we exited out of the application. All right, so this is the Go channels, and the last thing that I want to talk about, actually there are two more things that I want to talk about briefly, is the fact that we can do some buffered channel. So as I explained, the buffered were like with the analogy of a truck, and that's the same thing. I mean, that here you can just say 2, and by saying like by or 2 or 3, whatever, you basically in the second argument, you simply say how big your buffer will be. So if you say 2, that means you can this done channel to be block to block to to the goroutine that it's in. Before it blocks, it will accept 2 values. So it accepts 2 values, but it will start blocking it when you try to send the third value to this channel. So you see this, and then that gives you, sometimes that gives you better performance, because instead of like blocking everything all the time, you just give some time to other goroutines to do their works, until or you know what I'm saying. So there are cases where you will need this, and I'm sure that as you use goroutines and channels, there will be places where you say where you would need this and then start using it. So that means I can say done. Let's actually show some code example. Great. And then if I say if it's, and now I do have like, don't think about this guy for now. Let's uncomment that. And now it's execute this code. Great. So our done has now 1 value, and it executed as a, by the way, it's a queue, so we basically send value to queue underlying queue, and then it executes it. Great. And but when you say done again, it says, oh, wait, the done accepted only 2, or accepts only 2 values at the same time. So that means I can no longer send a value to that channel until someone reads at least one value from it, so that I can have a space, so that channel can have space for me to add new values to it or send new values to it. And that's pretty much how it works. So of course you can read it from there, but well, that's how you do things. All right, guys. So one more thing, and I'm done. As you see that we were using channels like in a bidirectional way, so we can read from a channel and we can write into a channel, or send a value to a channel, or receive value from a channel. But there are times when you want to make sure that people are only use a particular channel for in only or out only, and that means you can use this. So we have the syntax here that takes, if you define your channel like this, that means you can only send value to this channel, and if you do this, that means you can only receive value from this channel. Of course, it doesn't make sense in this context because we use the same channel for both reading and writing. But if you imagine that if you're passing your channels between functions as parameters, then one channel in one function you define as a parameter, you define your channel as a read only, and the other one is only write only. But you can of course pass the same channel between those functions, because when you pass the casting operation is implicit, so you can easily cast as on your functions, let's say, because you will eventually receive value from a channel that you actually send value, right? So when you define locals, when you pass your channels as arguments to those functions, you'll see that the parameters will be, or the channel will be implicitly cast from let's say send only to read only. You'll see what I'm talking about when you exercise channels in your own time, on your own time. So I think that's pretty much all. But the last thing about channels is they're actual reference types, by the way. So when you change the underlying value of a channel, it actually affects so the other places. So because there are references like slices and like maps. So just be careful about them, so that you don't end up wondering what happened to your channel or to your application. Alright guys, I hope this is a useful video. I hope I explained channels clearly, because at one point when I was watching videos, it wasn't explained like this, so you had to infer, you have to kind of memorize. But once you understood the logic which I explained in my video here, then the channel becomes really easy construct to work with. So alright guys, and hope to see you in my next video. Until then, bye.